This homework solutions video is for Science and Mechanics, Unit 7 Hydraulics, Section 1 Hydrostatics. Number 1. Find the pressure at the bottom of a tank filled with seawater that is 75 feet deep. In this problem, pressure is equal to the depth multiplied by the weight density of seawater. In this problem, the depth is 75 feet, and the weight density of seawater we have to find from our table of weight densities. So seawater, we're told, is 64.0 pound per cubic feet. And again, this is the value that we need, 64.0, because we're dealing with English units. So we multiply by 64.0 pounds per cubic feet. Multiplying, we end up with a pressure of approximately 4,800 pounds per square foot. Number 2. A large anchor weighs 500 newtons in air and 290 newtons when submerged in water. Find the buoyant force of the water. In this problem, our buoyant force is equal to the weight in air minus the weight in water. So our weight in air, we're told, is 500 newtons. The weight in water, we're told, is 290 newtons. So when we subtract those two values, 500 minus 290, we get a buoyant force of 210 newtons. Number 3. A filled water tower with a height of 100 meters sits on top of a hill. What is the pressure at the police station, which is 35 meters below the bottom of the water tower? In this problem, we might want to sketch out what's going on. So we have our top of the hill, we have the police station down below. So our water tower has a height of 100 meters, and the police station is 35 meters down at the bottom of the hill. And this picture is not drawn to scale. So again, we are trying to find the pressure at the police station, which is equal to the depth multiplied by the weight density of fresh water this time, because we're looking at a water tower. So the weight density of fresh water in metric units is 9,800 newtons per cubic meter. And then the depth that we're sitting at is 100 meters, which is the height of the water tower, plus 35 meters where the police station is sitting. So the total depth is 135 meters. Multiplying those two numbers together, we get approximately 1,323,000 newtons per square meter, which is the same thing as 1,323,000 pascals. And in this problem, this is a really large number of pascals that we're dealing with. So we can divide by 1,000 to figure out how many kilopascals we have, which is approximately 1,323 kilopascals, or kPa, and then rounding to 3 significant digits, we get 1,320 kilopascals, or kPa. Part number 2 then asks us, what is the pressure at the school, which is 13 meters above the police station? So we can draw a picture to show us what's going on in this entire problem. So again, our police station is down here, 35 meters below the base of the 100-meter tall water tower. And then the school is sitting up here, which is 13 meters above the police station. So we need to figure out what the total depth is first. So that depth is going to equal our 100-meter tall water tower plus the 35 meters to get us the depth at the police station. And then we're going to subtract 13 meters because our school is 13 meters above the police station. So this will give us the total depth. So the school is sitting 122 meters below the water tower. So now we can calculate the pressure by taking the depth times the weight density. And again, our depth is 122 meters. Our weight density for water is the same as it was before, 9,800 newtons per cubic meter. So then multiplying these two numbers together, we get a pressure of approximately 1,195,600 pascals. And again, we're going to convert this into kPa, kilopascals, by dividing by 1,000. And then rounding to 3 significant digits right away gives us approximately 1,200 kPa for the pressure at the school.